Shotade Olusegun. In today's live session, I'm going to share with us the true nature of time, light, and mass. This particular live session is going to be quite insightful. It's going to be informative. So I need you to call anybody that you know. Ask the person to come and join this live session because it's going to be quite informative. So now what we're going to treat today is going to be built on what the past scientists, the likes of Albert Einstein, Michael Faraday, James Maxwell, what they did, what they have, done in their lifetime to unravel the nature of energy. And so, energy in its pure form, we can actually liken that to light. And we know light is electricity is the same thing as light. And so we can get to have the idea of what light is by having electromagnetic wave. But basically what we're going to actually dive deeply into today is going to be more fascinating. It's going to be far more beyond what we have known, like what yes, like what we knew about light or energy, mass, and time. Well, actually, we may be so familiar with energy, mass, but time, we know time is quite invincible, and it is a tough topic for scientists to define. It is so difficult to define what time is, let alone to say this is what the nature of time is. But in this particular video, we're going to actually unravel that. We get to know what time is, and with that we can actually get to know more about the mechanics of the universe, and with that we can explain what consciousness is. If you are so conversant with my previous videos, if you have been following me, you know that there is this particular novel research discovery, and as you know already, that is if you have been following me, I have two research publications published on peer-reviewed journals. And so through these two research publications, I have this derived formula called formula of everything. And it's by applying this formula that I get to know that I get to know the nature, the true nature of consciousness. Now, in this video, I'm going to actually go deeply into that for us to really appreciate what consciousness is, But the most important thing is that with that formula, I was able to unify quantum mechanics to classical mechanics. And then with that, we get to know the true nature of the universe, get to know the true nature of things in the universe. So now with that, I can definitely tell you what the true nature of time is. So all I just need from you is just to pay attention, give me your rapt attention so that you can really understand this concept. So now, the first thing that we're going to actually dissect its definition is going to be energy. And when we're talking about energy, we can actually get the quantified example of that in form of light. And that is why I said we're going to get to know the true nature of light. Now, Einstein, about 1905, when he published his research, even before that time, He was so fascinated with the nature of time, and so he bombarded, anybody he could have around him with, questions as, is light wave the same thing as normal wave that we always observe, like, the wave on the pond? When you throw pedal into the pond, you have the wave formation. Is light wave the same with that? You understand? And then, you know, it was also bombarding people with questions like, if it could, move at the same speed as the speed of light, could that make light to be static? You understand? But we shouldn't forget that Maxwell said light cannot be static. In his own derivation of that electromagnetic wave, he said that light cannot be static. And with that, we need to actually dissect what makes the nature of light to be quite different from other conventional wave. You understand? So now the thing is this: if there is a boat, or yes, if there is a boat, or if there is a yes, if there is a boat, let me use that. If there is a boat on a lake or on a river, and if there is somebody right inside the boat, and if that boat is, wading its ways, or rather, let me say, wading its way, through the water, that would, give rise to wave formation. And the person right inside the boat observing the wave would actually see the wave being right there, static to the person. In this case, we're actually considering relativity, relative to the person. The wave will be static as the boat move, as the boat and the wave, and even the person right inside the boat, they move at the same speed. You understand? So the wave will appear static to that person. And with that, if we're now to consider the question that Einstein asked people, that if it could move at the same speed as the speed of light, would that make light to be static? It's a kind of insightful question to ask. But then, what would actually come to mind would be, of course, the wave will be static. But when you now consider what Maxwell said in his derivation, then you might not be so quick to say that. You understand? But then, if you would want to be so weird, or you would want to be so radical in your approach, then you might say probably maybe Maxwell was wrong. But then, if we look at another scenario, then may actually give us another opinion. So now let's look at another scenario. Let's say there is a mirror in front of you, and so if you move at the same speed as light, the light that reflect on your face will actually be living just as you move as well. So now, Now, by having, please, I need us to actually dissect this quite all right, because it's a kind of, it's a very tough scenario. I think that is what Einstein actually used to disprove the fact that light speed might be static. You understand? So what he now said was, if you are traveling at the same speed as light, and so the reflection of light on your face that will reflect on the mirror is also traveling at that same speed. If light is static, then it means that the light will never reach the mirror, and so you will not appear in the mirror. So now with that, do you think that is ideal? So definitely from that we can get to know that light is quite different from other forms of wave. You understand? So it is for that reason that we need to really understand the fact that the constancy of light speed will reach you at the same speed irrespective of your position to that light. You understand? So irrespective of where you are, whether you are approaching the light or you are moving away from the light, that would not either elongate the light or shrink the light. So light will always maintain its constancy. So now what I'm going to do in this live session is that we're going to explore the novel research discovery, and with that I'll be able to tell you how light works, how energy works. Now when I say energy and light, in this particular live session I'll be using light and energy interchangeably. So now we're going to see how light works relative to the momentum of time. You understand? So first of all, we need to know that the kind of relationship between time and energy or light is inverse. And so we're going to go deeply into that. So now let us dissect this definition of energy, and then let us quantify that, with something that we can actually relate with. So the definition of energy is a thermodynamic quantity equivalent to the capacity of a physical system to do work. A thermodynamic quantity equivalent to the capacity of a physical system to do work. That is what energy is defined as. I got this definition from one of my dictionaries. So with that, we can get to know that a thermodynamic quantity, it's a kind of quantity that can actually, or that can easily be transformed into, into probably many information. So with that, we can get to know that there is possibility for us to have, the propagation of light in form of wave, and have it in form of particle. So we say the particle of light, the carrier of light, the particle that serves as carrier of light is what? Is photon. So that's with that we can get to know that there is this wave particle duality, as it is often mentioned by scientists. So with this divination alone, we get to know that it's a kind of something that is so dynamic that can easily be transformed into either wave or particle. And then, the capacity of that, either by momentum or either by convergence, should be able to do work. That divination is ideal, is good. Is good for what we're trying to unravel right here. So now we have this wave pattern. I'm not a good artist, please forgive me. This might not be the way electromagnetic wave propagates in space, you understand, but basically it's just to give you an idea, give you something that you can observe, to give you a kind of visual representation of what I'm trying to, illustrate. So if we have the propagation of electric field in relativity to magnetic field, so as to have electromagnetic wave that can, generate light. So we have the magnetic wave perpendicular to the electric wave. So don't be deceived by this, my drawing. And then you can see the direction of the momentum when you follow the arrow. So now with this, we get to know that by having this alternating momentum of uh, electric field and magnetic field, we can, have light, and light is the same thing as electricity. So if we were to go back to the era of Michael Faraday, scientists were not, relating with natures, or rather, scientists were not relating with nature in, in a kind of unified way. They relate with it separately, either when they hear the banging of door, they might say that is one force. When you hear the striking of thunder, it's another force. So all these things have been, treated separately like that. But the idea of energy is not something that is not, feasible to scientists as at that time. But then Michael Faraday, you know, he was able to come up with this idea of electromagnetic wave, because when he was conducting the research, that time battery was newly invented, and so many scientists would connect wire to battery to do one or two things, and from there they got to realize that when you plug wire to a battery, if you should place a compass around that wire, then the compass will actually, rotate, and then it will move. How am I going to put it? Probably, yes, it will move perpendicular to the direction of that electric field, or yes, electric field. You understand? So with that, they were so amazed with that, because as at that time, scientists believed that electric current is more or less like, this flow of, just the same way we have flow of water in the pipe. So that is the way they often visualize that electric current. They visualize it as something that will be flowing through the wire. So to them, they believe the orientation of that magnetic momentum should be parallel to that of the wire. But Faraday was able to see beyond what other scientists could not see. So he suggested that probably maybe there was this maybe there was this field that is being projected by the wire, invisible, like invincible field that is being projected by the wire, and that might, be responsible for the rotation, the orientation of that compass relative to that momentum. And those that were there when he raised that, they actually abused him. They thought he didn't know what he was talking about, but basically all of them could really observe it, that what they could observe, or what is observable, is far different from what the scientists are teaching in the universities. You understand? So Michael Faraday continued with his own research, and then what he did next was he had to place the compass around the wire. Then he was able to see a pattern. From there, he could realize that the formation, the orientation of the compass were more or less, yes, the orientation of the compass related to that electric current of the wire could, form something that is circular. So with that pattern, Faraday realized that, of course, there was this invincible field that the wire was actually projecting. And so the next thing he did, he just put, a static magnetic right around a wire, then plugged that wire to the battery. Then he realized that magnet, the magnet that that is around the wire could actually make the wire to travel around. So with that, Faraday was totally convinced that as there is this electric current in the wire, it projects this kind of invincible field, and it is that field that is actually relating with the magnetic field to form what is known as electromagnetic field. And so that is why today we could talk about electromagnetic wave, and then today we can say electromagnetic wave is the same thing as light. You understand? So thanks to these scientists, thanks to Faraday, you understand? So now we know what energy is, we know what light is, but then another thing we need to know about light is that light is not like other wave. So we should always have it at the back of our minds that light will always sustain its constancy. Light will always sustain its constancy. So now let's move to the next one, which is mass. Now mass is defined as the property of a body that causes to have weight in a gravitational wave. The property of a body that causes to have weight in a gravitational field. Okay, so Mass, when you look at it, when something is said to have weight, what do we actually experience as a weight? What do we actually experience as that solid sensation? Well, what we often experience as solid sensation or as something that could be, termed as weight is inverse relationship, or rather, let me say the inverse relationship of energy to time. So there is this repulsive force that must be at play for us to actually have this sensation of something being heavy or being solid. So now, mass is defined as property of a body that causes something to have weight in a gravitational field. Now, what is that gravitational field? Gravitational field is a kind of field that actually, propagates towards, the central point of a body. You understand? But that is where it becomes so suspicious. If you say gravitational field is the propagation towards a central point of a body, and yet you say a body is something, a body is something that causes, weight in a gravitational field, it is quite suspicious in that sense. But then what we need to know is that the convergence that we actually lead to mass formation, we actually go towards the central, it will go towards the central point of time energy interaction. So the convergence that would allow for mass formation to occur, we actually go towards the converging point of time to energy. That is one thing you need to just have at the back of your mind. This time energy interaction is a novel research discovery, which I will, explain further as we progress. But then just have it at the back of your mind that the central point that mass convergence we have to go towards, we have to be the converging point of time to energy, because we can't say gravitational field is something that, that get converged, or is something that propagates towards, the central point of a body. So with that, I think it's more acceptable to use that definition. So when you look at what we have right here, you can see, the kind of convergence that we might likely have, which is, you see, it's in form of spiral formation. I decided to use this for us to, have a kind of, clear visuality, or clear, yes, or sorry, or clear visual of what I'm trying to illustrate right here. But then we'll now get to know why it has to be in this spiral formation. Because, some people might argue that light is a straight line, but then from the Faraday experiment, we had realized that the compass around the moving around the current of light could actually give us the pattern of circular formation. You understand? So basically, there is possibility, that is, the circular formation is not to say that light might not travel as a straight trajectory. You understand? But it is just to let us know that light, that is actually proving to us that light travels in form of wave. You understand? So now you can see this formation, the convergence. Now you see that we have the outermost of this big convergence to be blue. So that is going to represent the ideal solid formation that we have, you know, at the crust of Earth. You understand? So then right deeply inside the Earth, we could, have this energy density that is more unstable. And that is why we could actually have this eruption of earthquake right from the center of the Earth. You understand? So now the red spiral formation towards the central point of this circle is actually, giving us the inner condition of the earth. You understand? And so uh, we can actually liken that to energy density. Energy density is something that can easily be converted to pure energy, unlike mass density. Mass density is more solid in its form than energy density. So I just like to represent it with energy density because even in my novel research discovery, in this in the time energy wave model that I used to visually illustrate the application of formula of everything, there I realized that what we have in the Big Bang is quite different from what we have in the core singularity of the black hole. You understand? So what we have in the core singularity of Big Bang is different from what we have in the core singularity of black hole. So now, in the Big Bang, we have energy density. In the core singularity of the black hole, we have density. So now, why must it be like that? We must actually have this kind of asymmetric relationship for momentum to be constant. Because if we're to constantly have momentum, just as it has been said in the case of light, that light can never be static, then there must be this inherent asymmetric relationship between time and energy. You understand? So if we are to have mass density in core singularity of Big Bang, and then we have mass density in the core singularity of black hole, then what that is telling us is that they will both cancel out, and then we couldn't have had the universe as we have it today. So that is that. Now, when you look at this formation as we have it, we can call it Earth. You understand? So don't forget we have Sun also. But then you know that the outer region of the Sun, the outermost part of the Sun, is unstable, and that is why we could have this solar corona. This, you understand? So you can see that the outermost is in red. So the spiral formation of the outermost of Sun is red, which is energy density. So the innermost is blue, which is mass density. So with that, we can get to have, this clear picture of that spiral formation that would allow for that mass convergence. So okay, that being said, now let's move to time. Time, I know time is what most people, in this live session, time is what they would want to hear what its definition is. You understand? Because time is so difficult to define. It's a difficult concept to model. You understand? So basically, but right now in this live session, I'm going to define time for you. You two can just, you know, get my get the link, because I'm going to put the links to my research publication in the description section of this live video. You can get a copy of my research. You too work on it and meditate, ponder over this definition uh, for you to understand it quite all right. So the definition of time, like never before, is this: the electromagnetic speed of relativity scaling. Don't be disappointed with that definition. It's a good definition. In fact, it's ideal. Yes, that can actually give you, the genuine picture of what time is. Okay, so the thing is this: if you dissect the relationship of distance to time, then you get to know that time is always ahead of energy. Because when you dissect the amount of time it takes an object to travel from one point to another, you understand? You get to see that the time it takes that object to travel from one point to another will be time squared. You understand? And that is why, Einstein could have the speed of light to be c squared. You understand? So, and for us to have that, it simply means that energy is being compacted in square formation right inside time. But then that is not enough for us to have this, spiral formation to cause the convergence. We know we have the spiral formation in circular form. But then what I'm going to use to drive my point home will be equilateral triangle. And even if you have the square as we have it, don't forget that the square will be compacted at, it will be compacted. It will actually have compacted formation around it for it to actually align with circular formation. You understand? So same thing is applicable to this equilateral triangle, but with equilateral triangle you can actually, get to understand. You can easily get to understand how equilateral triangles that are being stacked upon each other, two equilateral triangles that are inversely arranged and stacked upon each other to form a star. You understand how they can actually be transformed to a circle. Don't forget, when you stack equilateral triangle that are inversely related to one another, to each other, on top each other, you are going to have a suspended part of the equilateral triangle around the stacked star that you get. And by having a compacted region, or rather by having compacted regions around the stacked equilateral triangles, then you are going to have what is known as constantly accelerated momentum that will shrink the slice of time to align with the curvature that will give you, that circular formation. So before I explain further, let's look at this diagram. This diagram is what is known as time energy wave model. In my research publication, there are two powerful tools that I use. The first one is formula of everything. That formula of everything is dT/dm equal to capital UM plus 4m. If you have been following me, you are already conversant with it. So now this formula, when you apply it, it's going to give you the entirety of what we have right here. Don't be shocked that how is it possible that that simple formation, that simple formula can actually, give rise to the diagram that we have right here. Yes, of course. Formula of everything can give you what we have right here. Let me explain. The thing is this: when you apply formula of everything, you can actually substitute the double M, the two M's in the formula. You can substitute it with either quantum mass or classical mass. Just substitute it with what you know. You understand? And you use that to get what you don't know. Then you realize that if you supply the mass worth of electron, the answer that you will get will be a classical counterpart answer. So for instance, let's say we use this, look at where I have 3D quantum mass. The quantum mass that we have is actually outside the constraint of time energy wave model. So I call it 3D, which is going to be a higher dimension to this particular entire diagram. So this entire diagram, I call it 2D. And so right inside the compacted equilateral triangle, which I call the nucleus of the future, don't forget that the flow of time is right from this classical realm. The classical region is where we have this dashed line to the top, while the quantum region is where we have this dashed line to the bottom. So now, so the flow of time is actually from this classical realm, through to this quantum realm, then to the higher dimension. So by having this interconnectivity from substrate dimension to higher dimension, the transiting point is what I call complex system. So I call the higher dimension relative to the substrate dimension, I call it complex level. You understand? So now it is ideal for us to have this complex system as we have it for us to be able to explain the reality of the universe. And I will, shed more light to that. So now we have this mass outside. Don't forget that the electron that we're supposed to have in the nucleus of the future, which is the nucleus of the quantum realm, the electron that we have there, the electron will be undefined until we have this positron of higher dimension being defined. That is when the electron of the substrate dimension can be defined. And what we have there, you are conversant with it. What we have there is known as quantum entanglement. Quantum entanglement. We all know that quantum entanglement can transmit information instantly. You understand? And there we get to know that time by default is instant. So for me to give you more definition to what time is all about, I will say time has two identities. Time by default is instant, but time is continuous when in relativistic scaling to energy. Now, energy too has two identities. Energy, on the other hand, is infinite by default.